In computer system security, role-based access control is an approach to restricting system access to authorized users. It is used by the majority of enterprises with more than 500 employees, and can implement mandatory access control or discretionary access control. RBAC is sometimes referred to as role-based security. Design. Within an organization, roles are created for various job functions. The permissions to perform certain operations are assigned to specific roles. Members or staff are assigned particular roles, and through those role assignments acquire the computer permissions to perform particular computer system functions. Since users are not assigned permissions directly, but only acquire them through their role, management of individual user rights becomes a matter of simply assigning appropriate roles to the user's account. This simplifies common operations, such as adding a user, or changing a user's department. 3 primary rules are defined for RBAC. Role assignment. A subject can exercise a permission only if the subject has selected or been assigned a role. Role authorization. A subject's active role must be authorized for the subject. With Rule 1 above, this rule ensures that users can take on only roles for which they are authorized. Permission authorization. A subject can exercise a permission only if the permission is authorized for the subject's active role. With Rules 1 and 2, this rule ensures that users can exercise only permissions for which they are authorized. Additional constraints may be applied as well, and roles can be combined in a hierarchy where higher-level roles subsume permissions owned by sub-roles. With the concepts of role hierarchy and constraints, one can control RBAC to create or simulate lattice-based access control. Thus RBAC can be considered to be a superset of LBAC. When defining an RBAC model, the following conventions are useful: S equals subject equals a person or automated agent, R equals role equals job function or title which defines an authority level, P equals permissions equals an approval of a mode of access to a resource, SE equals session equals a mapping involving S, R and or P, SA equals subject assignment, PA equals permission assignment, RH equals partially ordered role hierarchy. RH can also be written, a per million. A subject can have multiple roles. A role can have multiple subjects. A role can have many permissions. A permission can be assigned to many roles. An operation can be assigned many permissions. A permission can be assigned to many operations. A constraint places a restrictive rule on the potential inheritance of permissions from opposing roles, thus it can be used to achieve appropriate separation of duties. For example, the same person should not be allowed to both create a login account and to authorize the account creation. Thus, using set theory notation, and is a many-to-many permission-to-role assignment relation, and is a many-to-many subject-to-role assignment relation. A subject may have multiple simultaneous sessions with different permissions. Standardized levels. The NIST and CITS RBAC standard recognizes 3 levels of RBAC: core RBAC, hierarchical RBAC, which adds support for inheritance between roles, constrained RBAC, which adds separation of duties, relation to other models. RBAC is a flexible access control technology whose flexibility allows it to implement DAC or MAC. DAC with groups can emulate RBAC. MAC can simulate RBAC if the role graph is restricted to a tree rather than a partially ordered set. Prior to the development of RBAC, the Bell-LaPadula model was synonymous with MAC and file system permissions were synonymous with DAC. These were considered to be the only known models for access control. If a model was not BLP, it was considered to be a DAC model, and vice versa. Research in the late 1990s demonstrated that RBAC falls in neither category. Unlike context-based access control, RBAC does not look at the message context. RBAC has also been criticized for leading to role explosion, a problem in large enterprise systems which require access control of finer granularity than what RBAC can provide, as roles are inherently assigned to operations and data types. In resemblance to CBAC, an entity relationship-based access control system is able to secure instances of data by considering their association to the executing subject. RBAC differs from access control lists, used in traditional discretionary access control systems, in that it assigns permissions to specific operations with meaning in the organization, rather than to low-level data objects. For example, an access control list could be used to grant or deny write access to a particular system file, but it would not dictate how that file could be changed. In an RBAC-based system, an operation might be to create a credit account transaction in a financial application or to populate a blood sugar level test record in a medical application. The assignment of permission to perform a particular operation is meaningful, because the operations are granular with meaning within the application. RBAC has been shown to be particularly well suited to separation of duties requirements, which ensure that two or more people must be involved in authorizing critical operations. Necessary and sufficient conditions for safety of SOD in RBAC have been analyzed. An underlying principle of SOD is that no individual should be able to effect a breach of security through dual privilege. By extension, no person may hold a role that exercises audit, control or review authority over another, concurrently held role. Use and availability. The use of RBAC to manage user privileges within a single system or application is widely accepted as a best practice. Applications including Oracle DBMS, PostgreSQL 8.1, SAP R/3, ISIS Papyrus, Fusion Forge, Wikipedia, Microsoft Lync, Microsoft Active Directory, Microsoft SQL Server and operating systems implementing Linux, Security, Trusted BSD, and many others effectively implement some form of RBAC. A 2010 report prepared for NIST by the Research Triangle Institute analyzed the economic value of RBAC for enterprises, and estimated benefits per employee from reduced employee downtime, more efficient provisioning, and more efficient access control policy administration. In an organization with a heterogeneous IT infrastructure and requirements that span dozens or hundreds of systems and applications, using RBAC to manage sufficient roles and assign adequate role memberships becomes extremely complex without hierarchical creation of roles and privilege assignments. Newer systems extend the older NIST RBAC model to address the limitations of RBAC for enterprise-wide deployments. The NIST model was adopted as a standard by NCITS as ANSI NCITS 359-2004. A discussion of some of the design choices for the NIST model has also been published. Comparing with ACL, the primary alternative option to the RBAC model is the ACL model. A minimal RBAC model, RBACM, can be compared with an ACL mechanism, ACLG, where only groups are permitted as entries in the ACL. Barclay showed that RBACM and ACLG are equivalent. In modern SQL implementations, like ACL of the Cake PHP framework, ACL also manage groups and inheritance in a hierarchy of groups. So, specific modern ACL implementations can be compared with specific modern RBAC implementations, better than old implementations. RBAC and employees' responsibilities alignment. In aligning access rights to governance needs with the responsibility meter model in the frame of enterprise architecture, an expressive responsibility meter model has been defined and allows representing the existing responsibilities at the business layer and, thereby, allows engineering the access rights required to perform these responsibilities, at the application layer. A method has been proposed to define the access rights more accurately, considering the alignment of the responsibility and RBAC. See also, Access Control List, AGDLP, NIST RBAC Model, Discretionary Access Control, Security, Identity-Driven Networking, Lattice-Based Access Control, PERMIS, Security Classification, XACML, References. Further reading, David F. Ferriolo. D. Richard Kuhn. Ramasamy Chandra MLI. Role-Based Access Control. Artec House. ISBN A978-1-59693-113-8. External links, FAQ on the BAC models and standards, role-based access controls at NIST, XACML core and hierarchical role-based access control profile, Institute for Cybersecurity at the University of Texas San Antonio, Trustifier RBAC. A UBAC overview, practical experiences in implementing RBAC, role-based approach to Active Directory delegation, the monster called RBAC Virtual Strategy Magazine 2012, in computer system security, role-based access control is an approach to restricting system access to authorized users. It is used by the majority of enterprises with more than 500 employees, and can implement mandatory access control or discretionary access control. RBAC is sometimes referred to as role-based security. Design. Within an organization, roles are created for various job functions. The permissions to perform certain operations are assigned to specific roles. Members or staff are assigned particular roles, and through those role assignments acquire the computer permissions to perform particular computer system functions. Since users are not assigned permissions directly, but only acquire them through their role management role assignment, a subject can exercise a permission only if the subject has selected or been assigned a role. Role authorization. A subject's active role must be authorized for the subject. With Rule 1 above, this rule ensures that users can take on ownership of individual user rights becomes a matter of simply assigning appropriate roles to the user's account. This simplifies common operations, such as adding a user, or changing a user's department. 3 primary rules are defined for RBAC.